so we made you up. We put you as 7-4. I have no idea if that's true or not, but I just put 7-4. And then Daniel and James, the two brothers, we put one of them as 4-3 and one of them as 10-7, just so that we have some outliers in our data set to just kind of like have something to compare. So we made up some of these numbers. Sorry if that's not what you wanted to be, but we just put them in there, okay? So you have this, and you're going to have to fill that guy in. You can pause him if you want to, pause the video if you want to, and then fill these guys in. But do that now, and then we'll fill in the decimal one together here in just a second, okay? Did you guys get them all written down? No. Okay, do that real quick. Right fast.
7.
Then we'll do our decimals.
My eyes cannot focus.
Do you think how big you are as a baby has any correlation to how big you are as a
No.
You don't think so?
No.
I'm kind of on
Luke's 8'6".
I think
and
in
you were 7'10".
some cases maybe, but I don't think
I
so.
was a big baby.
And weight has no
You
correlation
still
to
are,
gender
yeah.
either, because
I
like
never changed.
like for adults, usually like males are taller than females, but for birth weight and stuff, there is no correlation to males or females. Like boy babies aren't necessarily bigger than girl babies.
But like scientific.
Now there is kind of a correlation to like I have a friend who birthed a very, very large child when he was born because she had type 1 diabetes and diabetic. If you're diabetic when you're pregnant, your baby a lot of times will be born larger, and her child is huge.
He's pretty big.
He's like a 120-pound 3-year-old or whatever. He's massive.
But Daniel,
Wait, why are they usually bigger?
That's not
Daniel,
right. That's not right.
When you have diabetes,
Yeah.
I don't know, just the way your body metabolizes calories and stuff, like the baby gets more
I don't know.
whatever.
I think I was past June.
So
And it like a week or
a lot of
And it
times that
makes
happens.
sense because like if you're born earlier, you're gonna be getting like more, you know,
attention.
attack.
More.
He's been through a week's worth
You're
more
gonna have
trauma.
more-
He's had to build that thick skin.
that's what I'm saying.
All right, let's convert these to decimals. So if you're still writing, you can still write. We'll go through. Oh, you need the bottom?
I need the
Maybe we'll start with the bottom and go to the top.
I also don't
Okay.
think
How many ounces are in a pound?
16.
16. So when we go to convert, like my weight down at the bottom, okay, you need me for not all of the questions, just the one box and whisker plot on the back side of this, okay? So you're not going to use me. You're going to cross me out for everything else except that one box and whisker plot that you will need, okay? But 710, if I'm converting him, you will do 7 point and we'll do 10 over 16. What's 10 divided by 16? Somebody do it as a decimal.
10 divided by 6.
10 divided by 16.
5.625.
No.
5.625. What is it?
10 divided by 16 is just 0.625.
Why
So
did I say 5.6?
this is 7.625, okay?
I was saying
Now,
5 or 8, so 0.6.
anybody else
I
that
can-
ends
I'm
with
not
a
stupid.
10 ounces is also going to be
I
0.625.
think
So
5
Clay
or 8.
was 8.625. And anybody else that is a 10? Libby is 7.625. We are exactly the same. And that's it.
Nuh-uh.
Jake? Oh, Jake is 8.625. Okay? So there's that. All of the 10s are going to be 0.625s. All right, let's start back down at the bottom again. Now let's do the 4 ounce one. What's 4 divided by 16? Do this in your head. 0.25. It's a fourth, right? So this is 7.25. Anybody else that is 0.4 or 4 ounces?
Nope.
I don't think so. 7 ounces.
Brother.
7 divided by 16 is?
Point.
16.
Oh.
Like 0.4.
0.4375. Okay, so 8.4375. We made up James's weight, but he will be 10.4375. Okay, anybody else that's sevens? Sevens. Carson, 8.4375. And that is all. All right, let's go back down to the next one. 3 ounces. What's 3 out of 16? No, that's not. 4. 0.1875. Okay, so 4.1875 is 3 ounces. Anybody else 3 ounces?
No.
That was not Daniel's actual weight, but we're making it up.
What is it?
0.1875. Okay, what is 8 ounces? 8 out of 16. A half. So that would be 7.5. And anybody else that's 8 ounces is also the 0.5s. So 8.5, 6.5. Anybody else 0.5s? Nope. 14 ounces. 14 out of 16 is 0.8625. I don't remember. 14 out of 16. 0.875. Okay, anybody else that's 14? I don't think so. 1 ounce, 1 out of 16 is 7.0625. 6 out of 16 is 0.375. Oh shoot, I missed one. Jalen is also 0.1. So 6.0625. And the last one that we have is Kyle, 8 ounces. He is 8.125, I think. Is that true?
Ma'am.
Yep. Okay. So there's the decimal. We have to convert to decimals. Where do you want me to go in the table?
Wait, hold up. I gotta
Just
make
pause
sure I got
there.
these numbers right.
Wait, no.
They are.
You don't right.
Ours are. I don't know what you did.
Why do we measure things in ounces?
I don't know. If we were in the metric system, it would be way easier.
Hold up. See, this is
Yeah,
what I did
but
different.
now we have to remember that
See,
like
I knew I
16
did
ounces in a
something.
pound, 12 inches in a foot, you know, all these other weird things where we could just remember the number 10 all across the board in the metric system, Right?
Smarter, so we.
Wait, scroll back down.
you know.
Past the
Scroll down.
Yeah, past the
Okay,
25.
there we are. Okay, we've converted to decimals. There we go.
Okay. Yeah, the one that I
All
got
right.
wrong was my own.
We need to put these onto a Google Sheet and find the average. And I've already done that. You're welcome. There is everybody's. So I need to find the average.
Let me just do it in my head real quick.
You're going to do it in your head. Average is 7.66. We'll go 2 decimal places. I'm going to write that down. Okay, put that at the bottom, 7.66. We also need the standard deviation, so I'm going to go equals ST. And it's going to ask me where you want. Make sure that when you're doing standard deviation, if you're doing it below the average, sometimes it will like to include the average in your standard deviation. Don't let it do that. Okay, so I just want those numbers, and I have 1.40 as my standard deviation if we round to 2 decimal places. Okay, so I put those up there. That is without my data value, okay, because we only need my data value for a box and whisker plot. So I put them there. 7.66 is the average. That is 7 pounds. How many ounces?
0.66.
Yeah,
8.
7.66. 0.5 would be 8 ounces. So like 710 would be about average, right? Okay.
Oh, if it was sealed.
A little bit. You're about average, okay? All right, or the front page. This is where we start answering questions. So we've got our data, we've got everything ready to go. Now we answer questions. The mean and standard deviation of our data, we just found that, 7.66 and 1.40. Okay? Fill in the following bell curve with your data. How the heck do I do that?
So the middle's gonna be 7.6.
The middle's going to be 7.66. What's the z-score for 7.66?
0.
0. He is 0. Then we add 1, so plus 1, plus 2, plus 3. And we subtract 1, subtract 2, subtract 3. But what are we actually adding and subtracting?
1.4.
1.4. That's my standard deviation. So if I add 1.4, I get 9.06, I believe. If I add 1.4 again, I get 10.46. If I add 1.4 again, I get 11.86. And that is my 1, 2, 3. So if I am 10.46 pounds on the nose, I have a z-score of 2. All right, now I subtract. This is 6.26. Subtract again, I get 4.86. Somebody check these.
Yes.
And I get 3.46.
Yes.
Yeah, beautiful. Okay, there is all of my stuff. All right, now I'm going to do the first group with you, and then I'll have you do the other 2 groups by yourself. But it says the range of one standard deviation of the mean away from the mean is from what number to what number?
6.25 to 9.0.
6.26.
6.26 to 9.06. That's the range that's within one standard deviation, okay?
You
The
are
range that's
weird.
within one standard deviation. All right. When we did the empirical rule, you guys remember that sheet that we had that like said this percent goes from here to here, this percent goes from here to here, this percent goes from here to here. Do you remember what those percentages were? 68 within 2 standard deviations was how much?
94.
95. And what's within 3 standard deviations? 99.7%. Okay, so to answer the next question, it says the percentage of data that should be within 1 standard deviation of the mean is how much?
Are you asking 68 or are you saying
68%. 68%.
One standard deviation.
One standard deviation on either side of the mean.
It doesn't say that.
That's a within one standard deviation of the mean. It could be either side of the mean. That's within one standard deviation. That means either side. Okay, 68% within one standard deviation of the mean. That's what it should be. Now, we're going to calculate and see what percent of our data actually lives there. So we're going from 6.26 to 9.06. Let me go up to the data. 6.06 to 9.26. I want to know who is in that range. So, Jayton, is she in that range?
Yes.
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 Haley, yes. Carson, yes.
Yes.
Jalen,
Yes.
Barely.
yes, she is actually.
Jake.
Yes.
Me.
No,
Yes.
wrong. Hold on.
You have the
I have the wrong number. It's 6.26, not
Oh,
6.06.
my
You're
goodness.
hating.
I'm going to the wrong number.
I'm so yes.
6.26, 9.06. This is where you guys pay attention and you yell and say, "This is commentary. You don't have the right
We're
number."
mad.
Okay.
We're not
So
ready.
6.26 is not.
No.
That's a no.
Me.
8.65. Yes.
Yes.
Yes. Yes. Yes.
Yes.
Yes. Yes.
Yes.
Yes.
No.
No. No.
Yes.
Yes. Yes. Yes. And we don't care about me right now.
Why do I
So,
care about you?
because you only need me for the backside. So, out of this, what percentage of our people actually live in that range?
A lot.
How do I figure that out?
Add them all up and then
How many do I have?
divide out what.
That's crazy.
Oh, I cannot.
13 out of
6.
16 is what percent?
You know.
13 out of 16. What percent?
81 1/4.
81.25%. Okay?
No,
So the empirical rule told me about 68%. Ours is actually less or more than that, 81.25%. Because we have more people that live in the middle. Whatever. Okay? All right, so you need to do the 2 and the 3 part where you're doing within 2 standard deviations, within 3 standard deviations, that type of thing. Okay? Let's go to the bottom part. You can do that here in a minute. Let's go to the bottom part. The z-score for my baby weight. For my baby weight. So this is going to be different for every person. Chase, put that away.
Okay.
You'll have time at the end. Like move it to a different spot so you're not tempted. Chase, move it away. The z-score for my baby weight. So this is individual to you. How do you calculate a z-score?
X minus X bar over top whatever
Divided by
over S.
the standard deviation. Okay, so I'm going to do this for me, and I guess Libby, because we have the same number. I am 625? Yes, minus, no, that's not right. What are we? Yeah, 7.65. Minus, what's the average?
7.66.
7.66 divided by the standard deviation, which is 1.40. And if I do that, I get like negative 0.0, is it 8? What is that? You guys don't do this. Do it for your own
Really
number.
small number.
7.625 minus 7.66 divided by 1.4. No, that is not right.
Should be negative 0.0 something.
Yeah. Is that right? Negative 0.03?
That sounds right.
I don't remember if that's what I got just a minute ago when I did it with the boys. Okay.
I have a question.
All right, so I am.
We are the boys.
No, I'm talking about the Lawrence boys.
Yeah, they skate.
Negative 0.03. That means I'm like 0.03 standard deviations below average. You figure out what you are. Okay, then we'll answer the next 2 questions. Did you figure out what you are?
Yeah.
Yep. All right, an extreme value is anybody who has a z-score above something or below something. What's considered to be extremely high or extremely low? Here's my average. What's extremely high? 2 above or 2 below, right? So-
literally only
If I have a z-score above 2 or a z-score below negative 2, I'm going to be an extreme value, all right?
Is anyone
So,
extreme?
my baby weight is or is not an extreme
Just those
value.
two?
Mine is not.
No,
An
only
extreme
Daniel.
value.
Only Daniel.
Okay?
I considered.
Is Daniel extreme?
Daniel's the
Is
only
James
one.
extreme?
Nope. James
Nope.
is not, but Daniel is.
James is like close to being extreme.
Close enough.
So, okay, there you go. All right, so make sure you answer that to your data. All right, let's go to the back side. This is where you're going to do most of this by yourself. You are doing a box plot. Without my data value, there are 16 numbers, so you have an even number of data points, 16 numbers. If you include my data value, which is the very last one, you have an odd number of data points. You have 17 numbers, right?
This Mrs. K
So
guy,
I want you to find the mean, median, mode,
brother.
or the min, median, max, that stuff, the 5-number summary for each of those. All right? Really quick. Let's do this.
No.
This is going to be a huge pain in the tushy
Put
tush.
them in order.
Put them in order.
No.
Start with
Yeah. Yeah.
Goes Daniel, Jalen.
Okay?
This is
All right. So I'm going to go
Lion.
Daniel. No, I'm going to go down here.
So 4.1875.
Hold on.
Why are you writing names?
Sure.
You don't use names.
Yeah, but we do need to know names because later we'll need to know names
Okay, well, you can look back.
for what you do.
later.
Well, you do whatever you want.
Like, for example, Libby and Mrs. Cumbercher both weigh the same. Okay.
Right.
But it's not gonna matter.
Do we
the
put the
order.
weight too, or just the?
Yes. Okay, so Daniel's first.
And then Jalen.
Okay, and then Jalen. Okay, so Daniel is 4.1875.
Down 6.06.
All right, so write this down. Jalen is
6.0625.
6.0625. Okay, who's next?
Haley, I think.
Chait, no.
It's me.
Is Haley and then Claire, right?
Yes.
Yeah.
Haley at 6.5, and then Claire at 6.875. 6.875.
I'm gonna cross these off as I go. 6.5. So all the sixes are done. True. I have one more six. 6.
Good deal. 7. I got a 7.
No, 4. Okay, who's next? 7.
7.0625.
Chase.
Maddie.
No,
No,
Maddie's 7.25. Chase is 7.0625.
Oh, you're there.
Okay, and then 7.25 is Maddie. Okay,
And then there's a 7.5.
and we have 7.5. All those are 8s. 7.5. Okay, and that's Connor. Don't include me yet. 7.625 is Libby.
What? Connor? Oh, Connor.
Okay,
Wrong Connor.
Connor.
We got 2 columns.
Yep.
Connor.
So are all the 7s done except me? Okay, let's go to 8s. Kyle, is he next?
Yes.
Kyle. Okay. Connor is a 0.4375. So Connor and Carson. We'll put Connor first because he's alphabetical. Sure.
I go. Me. Wait, how much do you weigh?
Connor
How
and
many Connors are there?
Wait, no.
6.
Luke had to come before them.
what?
Luke has to come
Oh
before
shoot.
Ah, yeah, you done this.
Luke, come on, man. You're causing problems even when you don't cause problems. 8.375. Okay, you're killing me.
One above Kyle. That's right, Kyle. You'll never be as good as me.
All right, so 8.4375. 8.4375. And this is
Kyle.
Connor. And who else? Carson? Oh, we're getting close. Okay, who's next? Clay and Jake are the same? Clay goes first because he's alphabetical.
We're doing it that way.
We don't care. It doesn't matter.
I've got a big question for you guys once we finish this.
Oh, I can't wait.
You better prepare yourself.
We are missing. Oh, Jayton. Oh, Jayton! No! You're killing me, girl. Gosh dang it. Jayton.
I was behind.
Jayton.
Yeah, I was like, I'm not even
Let's
there
go.
yet. I was like, she's like, what, after Chase or something? Like, do we have to rewrite the
I
whole
was waiting for her
thing?
to be like right after me.
No.
Just like, scrap everything. We're
Clay,
starting over.
Jake.
We're gonna.
We're really
birth
just a mess.
16 people. We're just starting
Jayton.
over.
Okay, now who's last? Oh, James.
Jameson.
James. 10.4375. Okay. Now, for your box and whisker plot, when you have to include me, is 7.625. I'll go after Libby.
I messed up, so I had to rewrite.
Mrs. K, 7.625. There you go. So, when you have to include me in your box and whisker plot, there he is. Okay? All right, can you guys do that box and whisker plots? The min, the max, the median, the Q1, the Q3, find what those are, okay? With 16 numbers and then include me and figure out where your stuff changes. Your min and max should not change for including me and not including me because I'm not a min or a max, right?
Yeah.
I'm a middle value. So your Q1, your median, and your Q3 should all change slightly with me versus without me, okay? That's why I wanted you to do both. Okay, good. Can I go away? Can I go back down?
If you feel like it.
Sure. Okay,
What?
back down.
No,
So here's your box and
no,
whisker plots. I'll go
there's
back.
One more.
Oh, you had one more. Write faster.
Hey, don't make fun of Carson. You're
Yeah,
fine.
just think
And it's
better.
literally on the sheet. Just move him.
Oh, I guess I was.
You could look for yourself. Okay,
No.
whatever.
I
All right,
know the names
So
now.
box and whisker plots. Then
He's legally blind.
we calculated the outlier using this method before, right? We take the 1.5 times the IQR. What does IQR stand for?
Internal.
It's Q3 minus Q1.
There you go.
Okay? So figure out what that number is, multiply it by 1.5 and add that to Q3 and figure out if anybody's outside of that range. If anybody's considered to be an outlier, above or beyond. Okay? And that is without my data, so don't use me. Okay? You're doing the first box and whisker plot. You're using that data to find the outliers. Do we have any outliers in our class? Answer that question. We might not. I have no idea. Then it says whose baby weight corresponds to these. Okay, so that's why we wrote names when we put them in order, right? We want to make sure we have the person it goes with. So you're going to find P30, P65, P90. Should we do one of those together?
Yeah.
Sure. P30 is 0.3 times, what do we take it times?
The standard.
No.
The total of
The total number of people. How many do we have?
16.
16, because we're doing it without me. So 0.3 times 16 is what? 4.8.
4.8.
Okay, 4.8. So I
Round up.
round up to
fifth
the
person.
fifth person. Who is the fifth person in order?
Chase.
Chase.
Good job, Chase. Way to
Chase.
go. What a legend.
Chase is the answer to part A. He is P30. Okay, now, here's the deal though. He is P30, but then when we go to find the percentile value for what he is, okay? So let's do this for Chase. I'm just going to show you how this works. Okay, when we convert to percentile, we do the number of people below you over the total number. Okay, so how many people are below Chase?
4.
4 out of a total of
16.
16. 4 over 16 is 0.25, right? So Chase actually is P25. How does that happen? Because here it said we got P30. Why is Chase P25 and P30 at the same time?
You special.
It's not.
Because there's a range.
Is he P25 or is he P30?
Because you round up, so in that rounding up range, you're still going to have.
The deal here is we only have 16 numbers. So you're going to have, like, Chase covers the 25th to, like, the 35th percentile, right? If you have any number in there, you're going to get the same person. Does that make sense? Because we only have 16 numbers. If we had 100 people, each person would have their own percent. Does that make sense? Okay? So that's why you're like, what? It's P25, but P30 up there. That's not quite right. So, yes, I understand that those aren't the same, but we only have 16 numbers, okay? Now, erase this. This is not what you want for your data point. You are going to do your own percentile, but I'm just showing you why there's an inconsistency between the two. Got it? Okay? All right, there you go. Can you figure out the rest of them? Do you have any questions before I set you free?
1, 2, 3, 4, 5, 6, 7, 8.
A little bit? Jayden? What do you got? Go up?
Should we FaceTime more?
You don't know what?
56%.
Okay. 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 All right, you guys got stuff to do. You got lots of work to do. There you go. I'll come back there, Carson. Okay. All right. Goodbye, people watching this video.